Yesterday we talked about perfect squares. Uh-oh, lost my marker. There it is. So if I had x plus, say, 3 to the second, what does that factor, once we multiply the factors, what quadratic do we create? X squared plus 6x plus 9. Come on, Jackson, put that away. So what is the pattern we realized? So if we take the factor, the 3 in that factor, multiply it by 2, and we get the middle term, and square it to get the last term. Okay? Well, so if I give you something like x squared minus 10x plus 25, is that a perfect square? Yes, it's x minus 5 squared. Okay? So if I told you, tell me the roots, it's really easy. X minus 5 to the second equals 0. And the only number that makes that 0 is 5. What if I give you a quadratic that's not a perfect square? So let's say x squared, we'll do plus 8x minus 9. Is that a perfect square? No. But we can use the idea of a perfect square to find the roots. And it might seem kind of silly today, and this is review from last year. So we want to do what is called complete the square. Looking at this, we know it's not a perfect square. What number does this need to be in order to be a perfect square? It needs to be a 16. We take the 8 and cut it in half, and we get 4, and 4 times 4 is 16. So to complete the square, I take this constant and I move it to the other side. X squared plus 8x, I'm going to leave a little blank, equals 9. What number do I need to add to this to make it a perfect square? 16. Does everybody know why? You cut the middle term in half, and then you square it. That's the pattern we learned the other day. So this is plus 16. Well, if I have a balance scale, and I all of a sudden add 16 to one side, we're unbalanced. And add it to the other side to let it even out. If I put weight on one side, I have to put the same amount of weight on the other side, and then it will balance. So I put plus 16 there. Yeah, if you subtracted 16, you'd even make it more unbalanced. So it's got whatever you do to one side, you have to do to the other. So now, because this is a perfect square, I can factor it. How does it factor? X plus 4. And it just so I don't know what I was going to say. It just so ends up that the other side is also a perfect square. How convenient. So now I can just square root. But there's a little trick that you're going to forget. Equals not 5. Plus or minus 5. Because whenever you square root x squared, so we have x to the second. Right. So this is plus or minus 5. And now we can find both roots by subtracting 4. What is plus or minus 5 minus 4? Don't say plus or minus 1. That doesn't work. So 5 minus 4, x equals 1. Or negative 5 minus 4 is negative 9. Boy, that was a lot of work. Let's look at the original problem. Can we factor the original problem? Two numbers that add to be 8 and multiply to be negative 9. X plus 9 and x minus 1. Why did we waste all of our time? The reason is, oh, sorry, I just factored it. I just made 9 times negative 1 is negative 9. 9 minus 1 is 8. So my roots are negative 9 and 1, which is exactly why what I got there. So the reason we do this is because some quadratics don't factor. If I gave you x squared plus 2x plus 2, there is no factorization of that. And completing the square will always work. Sometimes it's really hard, but completing the square always works. So if you have a quadratic that doesn't factor, and even if you graph it and it misses the x-axis, which means the roots are imaginary, completing the square will still work. So today, we're going to practice completing the square on the easy ones, the factorable ones. And then tomorrow we'll go into the ones that are a little bit more difficult. Yes, don't factor. You need to complete the square. Okay, let's try another one. X squared minus 12x plus 32. Is this one a perfect square? No. And even if it is, you can follow the steps and it will still work. So we're going to set this equal to 0. Move the 32 over. X squared minus 12x, leave a gap, equals negative 32. What number completes the square? 36. Plus 36. And if you've forgotten how we got that, negative 12 divided by 2 is negative 6. Negative 6 times negative 6 is 36. Yes? Yes. Uh-huh. So this number will always be positive because it's a perfect square. It's always going to be like 8 times 8 or negative 3 times negative 3. So this will always be positive. So we add 36 over there. Now that it's a perfect square, how does it factor? X minus 6. Good job. Squared equals, oh, I was really nice to you, 4, positive 4. Okay? So now I square root. X minus 6 equals plus or minus 2. Add the 6. X equals, don't say plus or minus 4. 8 and negative 2 and 6 is 4. Yes, Sadie? Yeah, that's what we'll work on tomorrow. So today, everything should be a perfect square. Should be. If it's not, number one's not, already, yeah. You're sneaky. Let me take a look. Hold on a second. My first step in this problem would be to move the 35. So I'm going to add 35. X squared plus 2x equals 35. What number completes the square here? What number do I put in that gap? 1. Half of 2 is 1. 1 squared is 1. So now it factors into x plus 1 to the second equals 35 and 1 is 36. So now I square root both sides. X plus 1 equals plus or minus 6. So my roots would be 7 and 5. And then I'm done. So work on problems 3, what did I say, 3 through 7?